Hey everyone, welcome back to another exciting coding session. Today we are going to tackle LeetCode problem number 334, increasing triplet subsequence. So, if you are new to LeetCode, it's a fantastic platform for practicing coding skills with algorithmic challenges. So, in today's video we are going to solve increasing triplet subsequence. So, let's understand the problem statement correctly. We are given an array of integers and our task is to determine whether there exists a triplet subsequence in the array such that the elements are in increasing order. Means suppose that this is I and this is j and this is k, so there should be this type of relation: I is less than j and j should be less than k. If this condition is valid, we have to return true, and for each element it should be true, like 2 3 4 and 4 3 4 5, like that. And in second test case, we as we can see there is no relation such as I less than j less than k, so we have to return false. I hope you understood it. So let's understand the approach. How are we going to solve this problem? So to solve this problem, we will iterate through each element and we will create two variables, first and second. Let me be clear. Please listen to me carefully. In to solve these types of problem, we would need two variables for first and second. First will store the first element and second will store the second element, such as we will iterate through each element and we will check whether the num is less than f. In the first place, we will store the maximum length of maximum number in this first and second variable, like so. In the first, we will store max value in first and second variable. Then we will check only three conditions to check whether it's triplet increasing subsequence or not. We just have to check three conditions, which are, so our first condition would be if num of I is less than equal to f, means this first element if is less than equal to f, so we have to store this element in this f variable. So in the start, we have stored maximum value in our first variable, so this condition would be true, so we store this 1 in this first element, and after that we have to check a condition for second element, as we see. So after the first case, in iteration 2, we will check if num of I is less than equal to s. First we check num of I is less than equal to f. So in first we have stored 1 in f, so there would be 1. So 1 is 2 is less than equal to 1, no, so this condition is false. And then we will go in this second elif case. Num of I is less than equal to s, so we have stored maximum value in this s variable. So yes, this condition is true, so we'll store this 2 in this s variable. And after the third case, we know that 3 is not less than equal to 1, 3 is not less than equal to 2, so we have to return true. Don't worry if you didn't understand it clearly. We will do dry run of this code for you to better understand. So let's code it. Of course we would need an for loop to iterate through each element. See, we needed two pointers, first and second. So in first we will store integer dot max value, You know it, right? Why we are storing max value? Because in the first case it should be true. So we need a for loop to iterate through each element of this array, right? So the starting value of will be 0 and I is less than nums dot length and I plus plus. So as we talked, we need two conditions to check whether num of I is less than or equal to. It can be equal, that can be true, so that is why we have to check. If it is less than equal to f, then we have to store that element in the first variable. So we will store num of I here, else if we have to check whether nums of I is less than equal to s. If it is, store that element into s. Else if these both conditions are false, just return true. Else after the full iteration, if there are no triplet subsequence, just return false. Simple, right? So as you can see, we have created two elements, first and second. First would be the maximum value of integer, second would be the maximum value of integer. So we just have to check num of I is less than equal to f. If yes, store that element into f. If num of I is less than equal to s, just store that element into s. And if these both are conditions are false, just return true. And let's try to run the code. So as we can see, we have cleared all the test cases. Let's try to submit the code. So as you can see, we have submitted the code. So yeah, it's good. If you didn't understand the code yet, let's understand the dry run of the code, then you will understand it better. So let's do the dry run of this code. So let's start the dry run of the code for this case. In the first, we have declared f to maximum value and s to maximum value. So there would be f and s two variables. F is storing the maximum value of integers and s is storing the maximum value of integers. So in first iteration f would be, so in first iteration, let's see what will happen. What is nums of I? At index 0 there is nums of I. So nums of I is 1. So we have to check whether 1 is less than or equal to f. So yeah, the condition is true. So we will store num of I is what? 1. So we will store 1 in this f variable. So f is what? 1. So we have stored 1 in this f variable in our first iteration, and in iteration 2, when I becomes 1, so when I becomes 1, it will first check num of I is less than or equal to f. So f is what? So f is what? F is 1. So 1 is less than, and num of I is what? Num of I at index 1. So num of I is 2. So we have to check 2 is less than equal to 1. So the condition is false. So we have to check 2 is less than equal to s. S is storing the maximum value, so yeah, this condition is true. So s equal to nums of I. So nums of I is, then s is becomes 2. And in third iteration, in when the I becomes 2, this 3, when the index is 2 and the value is 3, so we have to check 3 is less than equal to f. So 3 is less than equal to 1, condition is false. 3 is less than equal to 2, as is 2, so yes, condition is false, so we have to return true. And again we have to check for the value, for the 4 value. So 4 is less than equal to 1, false. 4 is less than equal to 2, no, right? So we have to again return true. And for same for 5, so we have to check, is 5 is less than equal to 1, no. Is 5 is less than equal to 2, no. So we have to return true, and else the output would be true. Right? So as we talk about the time complexity of this code, so the time complexity of this code is big of n, and the space complexity for this code is big of 1, because we are not using any extra space. Alright, so let's wrap up for our solution to LeetCode problem 334, increasing triplets subsequence. Understanding the problems and devising an efficient approach allowed us to solve it effectively. If you found this helpful, don't forget to like and share and subscribe for more coding tutorials. Happy coding!